Hi everyone, let's solve this problem. Kth smallest element in a BST. Given a root of a binary search tree and an integer k, return the kth smallest element of all the values of all the nodes in the tree. And also kth is one indexed. So array can be a zero index. So they are saying that one index is nothing but first element will be one index. So k is 1. In this case, let's understand this with a tree here. So now this is a BST. In the BST, the property is that all the elements on the left will be smaller than all root, and all the elements on the right will be greater than the root. So in this case, if I have to mention this property, the property will be something like all of left will be less than root less than all of right. This is the BST property, because of which we will be able to figure out a use case here. Now if you see, we have couple of traversals in our tree as well. So one of them is Inorder Traversal. Inorder Traversal, what does it do? It again says first we will traverse left and then root and then right. So this is the traversal order of our Inorder Traversal. So now let me traverse it and show you what happens here. So let's maintain an array. Now in this case, when I am at this root, I will move to the left. Since it does not have any left children, the root will be here and I will be able to insert 1 into my array. And then now I will be moving on to the right since root is already processed. Now this particular 2 element does not have any left children or right children. So I will be processing the 2 node. And then since all the children on the left of this root is done, I will be processing the root node here. So because of that, I can insert it into my array. Now since left and root is done, what do I am left with? Right. But for this node, there are no left and right children, so I can just process the node directly. So I'll insert it. And here we are given k as 1. It's nothing, since this is 1 indexed and array is 0 index, I can directly say that I should be taking the 0th element from the array. The answer is 1. So we get the answer here, right? Let's also look into one more example to understand it better. So now I am at the root. I'll move on to the left and it has left nodes. I'll move on to left. I'll move on to the left. Now it does not have any further left nodes. So what should I do? I should be inserting 1 into my array, visited array. And then what will I do? I will move back to the root. Root is present, so I will process my root. And then left subtree is done for the root node 3. And now we have to process the node 3. So I will be inserting 3 here. Next, since left and root are done, I will be processing the right child here. So I will be inserting 4. Now, since the left of the root is done, I will be processing the root here. So I will be inserting 5 here. And since left and root is done, I will be moving on to the right side, and right side child node does not have any children, so we can just process the 6 as it is. So I will be inserting it into the array. So now let me also give them indexes for better understanding: 0, 1, 2, 3, 4 and 5. So based on this, if k is 3, we should go for k minus 1, nothing but 2. At second index we have 3. That is our answer, because again the k is 1 index and our array is 0 index. That's the only reason. So now can we optimize it further without having an array? Because we just need this answer and we don't really need all other nodes. And since we are able to get this answer because when we process the tree in the in order, we get a sorted array because of the BST properties, because of which we can directly access k minus 1. But we actually do not need all the elements, and we just need the k minus 1th instance. So let's now try to get look into it in a different approach. So let me start again. So I am here at 5. So I'll move on to the left. I move on to the left. I move on to the left. Okay, let me also add a count. My count is 3 currently. So next, when I am at 1, there are no left children, so I am visiting this, right? So before visiting that, I will just reduce my count to 2 and I visit 1. I am done with this. Now I will move back to this. There are no this is the left children processing is done, so this is the root. I can visit it. Before visiting it, I will reduce it to 1 more, and then I visit it. Since the left subtree is done, I'll move to the root node of this particular tree. So at this particular node, I will again decrement my count, and what can I do? Since the count is 0, that means we have visited 3 nodes so far. We are done. And when the count is 0, I know that this will be the answer. So we are going to code this solution. So basically, instead of maintaining an array, we will just maintain a count to check the position, and whenever we are at the 0th position, we will return the array. We will return the answer, sorry. So now let's try to code it up. So in this case, first let's define answer. We do not have any answer as of now, so let's not give any value, return answer. And then we also have to give the count is nothing but k. And also let's define an array, sorry, a function where it takes a root value, and inside this we all know that if there is no root, we will return, and in the in order we are returning root dot left. And before visiting our node, we are decrementing the count, and if count is equals to 0, we are assigning our root dot value to our answer, and we can actually return from here itself because we found our element, kth element. So root dot right, we are traversing on the right side. So now let's try to run this code. Okay, sorry, we did not call the func method we have introduced, so we are calling it with the root, and answer will be returned. Yeah, now let's try to run it up. We have ran our method and it's working fine. Now let's submit it. Yeah, it's working fine. So now let's understand the time and space complexity of this solution. Time complexity is nothing but big O of h or n. Basically, a worst case it would be n. Let's say for example the kth smallest is equal to n, then we obviously will be able to like, let's say for example, what I'm trying to say is k is greater than or equal to n. What will happen is, like, we will traverse all the elements. So worst case is obviously big O of n, and space complexity is big O of h, but worst case again it will be big O of n, because we might have to traverse all the elements, and if it's a skewed tree, then all the nodes will be on one side of it, so it will be big O of n. So yeah, this is the space and time complexity. I hope the solution is clear. Thank you.